This conference will now be recorded.
Hello, everyone. My name is Maurice McHugh. I'm the Deputy Lead and Future Capabilities Manager for the Geo Product Readiness and Operations team. Welcome to the Satellite Book Club number 206. Today's presentation is LightningCast Transition to Operations, presented by John Cintineo, excuse me, research meteorologist for the Warning Research and Development Division at the National Severe Storms Lab. And our facilitator today is Donal Harrigan, Science and Operations Officer at the Weather Forecast Office, Miami, Florida. Just some reminders before we get going. First of all, this session is being recorded, so please be aware of that. Please mute your microphones, turn off your webcam. The Q&A will be after the presentation. I would like to encourage attendees to post their questions in the chat room, and we will field them through there. Excuse me. Also, please sign in with your full names or specify your full name when asking a question in the chat. The reminder that we're looking for future presenters, and if you feel that you have something to contribute, please contact the TowerS team. The training team can help with any training materials that may be unavailable and contact Ross Van Til for information or questions regarding that. Thank you to the Geo and Leo programs, our facilitator, Donal Harrigan, and John Cintineo, excuse me, holds degrees in atmospheric science from Cornell University and the University of Oklahoma. After graduate studies, he became a researcher at the Cooperative Institute for Meteorological Satellite Studies, CIMSS, at the University of Wisconsin. At CIMSS, John worked on evaluating satellite-based volcanic ash algorithms, studied cloud trends in severe and non-severe convection, and developed the ProbSevere suite of models. In 2024, he joined NOAA's National Severe Storms Lab. His current research focuses on improving the prediction of convective hazards in the 0 to 6 hour timeframe using mainly satellite radar and lightning observations with machine learning methods. John is still stationed in Madison, Wisconsin. John, welcome back to the Satellite Book Club, and feel free to take it away from here.
Yeah, thank you for that introduction. Thanks for having me back. Happy to discuss this topic, this transition. I want to thank my colleagues, Mike Pavlonis, Justin Siegliff, Lena Heiser, and Levi Fonts for all their contributions and work on the project. So I think this should be a relatively short talk, hopefully lots of time for questions. For those of you who aren't familiar with LightningCast, it's an AI or a deep learning model that uses images of ABI data to predict next hour lightning occurrence. So you can see the inputs below, 4 channels from the VIS, near infrared and long wave infrared bands. We use the full spatial resolution of each of those channels, and it was trained against 60-minute accumulations of GLM's flash extent density product. So the output is simply the probability of lightning in the next 60 minutes at every location, and it's probability of lightning as observed by GLM. The Weather Service currently uses an experimental feed of LightningCast procured by CIMSS. Okay, so I'll get right into it with a who, what, where, when type questions. So LightningCast will be operational in NESDIS's Common Cloud framework at OSPO. And in terms of when, we're hopeful it'll be no later than March of 2025. So it's at about 6 months or so. The main users of LightningCast are National Weather Service, WFOs, but also some centers for environmental prediction. Several other federal agencies are also really interested in the output from LightningCast, including the FAA, the Bureau of Land Management. And then there are a number of interested users from academia and other research institutes and private companies as well. We're already using some of the experimental feed data. The operational operationally produced products include the NetCDF, which will be for AWIPS and compatible with the AWIPS resource that LightningCast uses. GeoJSON, which is human readable, lightweight way to convey geospatial information. It's used in many, many web applications. And then GR level place files will also be operational. We recognize that this is an important format that forecasters use in the offices, but especially out in the field when they're providing on-site decision support. You can see the sectors that will be supported operationally. It goes east and west, the CONUS and PACUS sectors at 5-minute resolution, 4 mesoscale sectors at 1-minute resolution. And then for goes west, a couple of full disk subsets, including Alaska and Western Canada, and then in American Samoa. And for goes east, there's a full disk subset at 10-minute cadence or resolution that covers OPCs and TAFBs offshore zones, which do extend to, I think, off the coast of Ecuador, northern Peru. And then for Himawari, there will be a sector for Guam's area of responsibility, which is quite large, about the size of CONUS or PACUS sector. Okay, what will be archived? The NetCDFs will be archived, and those contain both the parallax corrected LightningCast values and the uncorrected values. And only the uncorrected probabilities in the GeoJSON format will be archived. I don't have specifics on location yet. Hopefully somewhere in a cloud, it'll be easy to access, but will be archived at NCEI. What will not be archived? The parallax corrected GeoJSONs and the GR place files will not be archived, but these can be readily recreated from the uncorrected GeoJSONs, and CIMSS can provide a script for facilitating that. I think things like the JSONs or the GR place files be really useful for offices, for training purposes or postmortems, presentations. So we want to support that as well. Okay, what will not be initially operational? These point-based Lightning dashboards will not be initially operational. This is a web-based capability. If you're not familiar with it, basically from our website, there are several layers, static and dynamic layers at given points, where if you click a point and the link, then it brings up a new browser tab with these dashboards, or basically meteograms of the LightningCast probabilities and the GLM observed flash counts for both goes east and goes west where applicable. So it has the 5-minute update refresh rate, and in this case the red line, and if your location is covered by a meso sector, you also have the 1-minute updating probabilities, and then also the GLM flash centroid counts within about 5 miles and 10-mile radii. So this is a really good way, we think, for forecasters and users just to see how the lightning potential is changing at a given location. So we are in conversations with NESDIS to hopefully make this a follow-on operational capability, but that's not guaranteed yet. So we would love your feedback, further feedback on this. If you have used it, you can make that known in your through the appropriate channels or up the chain of command, or also you can just email us and we have a conversation, and I'd like to hear your feedback. If you're not familiar with this, if you're a forecaster, I highly encourage you to take a look at the links here and check these out for static layers at all TAF sites, many college football stadiums, and then current fire incidents, which do update dynamically. Part of these dashboards that won't be initially operational are what we call on-demand dashboards. It's essentially the same idea, except right now we have a form where you can submit any location, just submit a name for an event, the location, the start and end times, and you'll automatically generate one of these sets of dashboards for your event. So this could be really important for things like DSS that might not be really close to any of those static points. So this is all automated. Again, I strongly encourage you to test this out if you haven't, and if you're interested, and we really want to hear your feedback. I believe CIMSS will continue to create these dashboards on a best effort basis, and hopefully it'll become operational, but if it isn't, then probably the dashboards will go away. So we really want to hear your feedback on this. And we do keep track of some of these on-demand dashboard requests. We've had, looks like about 110 in the last year or so. So you can see a smattering of requests from around the country, and these have been for events such as state fairs, NFL games, and even ostrich and camel races. I don't know if I've ever heard of that, but I really want to go to the next one. So, right, you can pick any point you want and generate a dashboard that way. At the 2024 hazardous weather testbed, we tested out this capability and gathered feedback from forecasters. At the end of the week, each week they were basically asked if this was an operational ability, how often would you use these dashboards? And it's a small sample size, 16 forecasters, but we do think gives us a little bit of an idea of how often they would be used. On the left, for the on-demand dashboards, you can see 12 out of 16 said they would use the dashboards in applicable situations regularly or all the time, and all but one said they would use it at least occasionally. And then for the static dashboards, just similar, 9 out of 16 said they would use the static dashboards regularly or all the time, and all but one said they would use it at least occasionally. So we were really encouraged by this feedback. We think this is an important capability, but ultimately we need to hear from more forecasters about how or if they would use these dashboards. Okay, so what do you need to do to be ready for when LightningCast is operational? We don't have a lot of details yet, but we can say for the AWIPS Net CDFs, you can at least stay up to date with the TowerS RPM releases. They help organize all of the AWIPS and Cave XML configs to make sure everything's flowing properly. Then you'll need to also subscribe from the proper distribution channel or combination of channels. So that's the SBN, PDA, or LDM. While we're not certain yet, it's starting to look like that LightningCast might be distributed at least on the PDA, possibly other channels as well. And some communication will definitely come out about when and which channel and how to do that. And also, you'll need to turn off the LightningCast feed from CIMSS. There will be some overlap period, probably a couple months between the experimental and operational feeds. And if you want to use the GR place files, it should be pretty simple. You just need to change the URLs in your place file config in that GR software from the Wisconsin CIMSS ones to ones provided by NESIS or NWS. And again, communication will come out about the timing of that. I wanted to highlight another parallel effort that's concurrent to this transition to NESDIS and NOAA operations. At CIMSS, we have this community satellite processing package, CSPP, and it generates satellite products, in this case from geostationary data, and it's simple to install and run in any Unix or Linux type environment, and there's a beta release coming out basically any day now. The idea here is that you use the ABI level 1 products to create images or NetCDFs and things like that for the level 1 imagery, but also the level 2 imagery. So they created a LightningCast software package too, so that you too can generate PNGs or NetCDFs, GeoJSONs, even GR place files for LightningCast. You could run the model. I think this could be really good capability again for offline analysis, postmortems, presentations, training exercises, and for entities outside the National Weather Service, this could be used as a part of an operational system. So this also works with Himawari's AHI data as well. So if you're interested, please check out this beta release coming very, very soon. Lastly, I just wanted to highlight some of our current research to improve LightningCast. One thing we want to improve upon is predicting lightning initiation. We recognize how important that can be for public safety. So one thing we're doing is combining Earth Network's ground-based lightning with GLM lightning, and that can be difficult to do. There's a lot of complexity there, but if you are only interested in a binary lightning or no lightning, that actually reduces quite a bit of the complexity. So that's one thing we're working on to iterate and train the model to do a little better on lightning initiation. We're investigating the impacts of some MRMS predictors, mainly reflectivity at -10°C level, and some preliminary results are really promising from that. A few things we want to ensure is that we aren't diminishing lead time to lightning initiation, right? If we don't want the model to wait for reflectivity at -10°C. We also want to make sure the model works really well in areas where we don't have MRMS, right? In these grayed out areas over here. The UNet model has worked really well for LightningCast and a lot of different applications, but there are some more complex models we're testing, including transformers, to see if they might be a little more powerful to improve the predictions. And then forecasters often use video data to make decisions, so we want to use time sequences of satellite images to see if we can improve predictions that way, not only for developing storms, but already developed areas of convection, and maybe we could do a little better job on where and how that convection is affecting in the next 1 to 2 hours. So a lot of exciting research happening, and we're hoping this transition to operations will really help facilitate some of these research efforts that prove fruitful. And I believe that is all I have. Thank you all for listening. Happy to take any questions.
Awesome. Thank you, John, so much for that presentation. So I encourage everybody to ask some questions if you have them, whether it be put them in chat or just raise your hand or speak up, take yourself off of mute. But first, we've got a couple of announcements. Let's see here. So we'd like for you to share any feedback you have on this session in the short survey that's linked again from Lee there in the chat room. In a week from today, that'll be Thursday, September 19th at noon, Melissa Huffman, the meteorologist in charge of the National Weather Service Southern Region Headquarters ROC in Fort Worth, will present Mastering the Mesosector, Coordinating Considerations for GOES Mesosector Imagery. If you have any topics that you would like to present on, contact the TowerS team, that's Kashad Bowman or Emily Maddox for questions also on getting that set up, or if you need help with any of the satellite products coming through the TowerS RPM package that we get through AWIPS, they're happy to help and are very responsive. Okay, so I'm going to go through and read some questions that we might have here. John, so let's see what we got. Okay, there's a question about the dashboard probability plots. The yellow and red lines for probability of lightning in a minute or 5 minutes. Ian says, I see the probability of 1 minute often above the probability of 5 minutes. How do I interpret that?
Yeah, one second. Let me see if I can get my slides back up here. I'm not sure what happened to them. Okay, hopefully you can see that now. Yeah, the question was how do you interpret the 1 minute probability? Sometimes they're higher than the 5 minute probabilities. Yeah, there's definitely some nuance there. The model, LightningCast model, it's a UNet, so it needs some spatial context to make predictions. So a lot of times if your point is towards the edge of like a mesoscale model, it doesn't have that full spatial window or spatial context to capture all that information. So the probabilities could be quite a bit different from the CONUS 5 minute probabilities. Probably what's happening there. And then other times, right, if you're just getting a higher refresh rate, the satellite imagery is evolving and developing faster than the 5 minute CONUS imagery can see. So sometimes you'll get ramp ups in the 1 minute imagery or probabilities before the 5 minute, but then the 5 minute usually in that case should follow close behind.
Thanks for that, John. I'll say down here, we use it quite a bit in the wet season for summertime sea breeze convection, scattered convection. And one thing I've heard forecasters mention is essentially how polluted the dashboard or the display gets once you start getting a lot of storms around. And I know that you mentioned some focus on the initiation. So I guess question being are there any efforts underway to try to better resolve the lightning initiation for individual storms within that kind of larger complex of storms, or maybe even a separate product that's initiation by storm? I imagine some of that is kind of tough to resolve, but
it is. I think part of that is in using the GLM as our truth data. Right, it has a pretty coarse spatial resolution, and then we're also trying to predict the next hour, and sometimes you don't know exactly where storms are going to be even in that short time frame. So we chose GLM because it's you get this to some extent the spatial aspect of the lightning, but we could do something like using GLM or Earth networks, just flash points or flash centroids, and put it on a finer scale grid. That would be a very different looking product. But it would give you a little more specificity, especially in the cores of storms. But my hunch is that it wouldn't work as well in anvil lightning, stratiform lightning, which right now could still be challenging too. But that is something we've thought about. We've gotten that feedback several times. It's something we could definitely look into further.
Thank you. Yeah, Scott had a comment. Scott Lindstrom said that he'll be giving a showcase presentation on CSPP Geo LightningCast beta software at the NWA next week in Texas, just for everybody's information there. John, are there plans to produce the full disk products in the future?
Yeah, the full disk products, it takes a lot of computational horsepower to do that, especially with a 0.5 kilometer viz on the full disk. We don't currently have plans to do that, and that's to save on resources. But also these having these subsets helps reduce latency too, because it just takes longer to do the full disk. So there aren't any current plans to do that, but if we hear about or recognize some need to just do full disk, and if we do it fast enough and cheaply enough, then I think we can definitely do that.
Okay, and what would you expect to be the most impactful development from your current LightningCast research?
Oh, yeah. I think I'll just go to that slide real quick. Yeah, I think each of these will have impact. I mean, definitely the MRMS is let's see, we'll have a lot of impact. We just want to make sure it's not hurting in places that are important to users, like outside of radar coverage and for lightning initiation. I think just using ENI and this better analysis of total lightning will help. I've seen lots of times where ENI flashes are well before GLM. I've seen times where GLM sees flashes before ENI. So just having some more unified analysis of lightning, I think, will definitely help. And though this does add a lot of complexity, I really do think using a time sequence of satellite images should help. Not certain on that, but right, we all look at imagery and loops and animations, and there's definitely context and information there that you get from that, as opposed to just one time frame of images. So
Okay,
maybe all
thanks.
the above.
Yep. Well, I don't see any other questions right now. You still have a chance to type in some questions while we wrap up here, but the folks will put a link in chat here to the SBC presenter facilitator forum. So not only are they looking for people to present topics, but if you would like to be a facilitator, you can use the link that's being pasted in there now to sign up. And again, a reminder to share any feedback that you have on this session or other sessions in a short survey that will also be relinked. Let's see, I think we got another question that came in from Ian again here. Is there an ATBD or paper about the algorithm and training that I can read?
Yeah, there's a paper published in Weather and Forecasting in 2022. LightningCast is in the title, so if you just search on that, you should be able to find it. We do have a draft of an ATBD, and I assume that'll be finalized soon, and that could probably be communicated out with some of the other communication on the nuts and bolts of how to get connected to the operational feed.
Okay, thank you, Ian, for your questions, and thank you, John, for your answers and your time today. So it looks like that'll do it for the Q&A session. Again, please use the link in there to provide any feedback that you may have. I'll send it back to Morris right now for some final remarks.
John, thanks again for returning to present on the transition of this very important product for the Weather Service. And Donald, thanks so much for facilitating so well this session. Thank you everyone for your attendance today, and please remember to join us next week at the same time for Melissa Huffman's presentation on the NWS Southern Region Headquarters. Thank you all.
Thanks.